Hey y'all. Today's objective is proportionality. Proportionality. The root word obviously being proportion. So here's the old vocabulary that we've gone through. Ratio, unit rate, and proportion. We talked about ratios, talked about unit rates, talked about proportions. So we're going to kind of combine all of those. And there are two new vocabulary words that you need to get down. Constant of proportionality. Also kind of known as the unit rate. It's the constant multiplier in a proportional relationship. Constant multiplier. So remember that word multiplier. The other word is proportional. It's a term used when ratios are equal. So if you have a proportion, if you have two equal ratios, then that's considered proportional. So get down your new vocabulary. Alright, so example 1. Let me show you how to deal with it with tables. We're going to be going through three things today. Tables, equations, and graphs. So tables. Example A, we have, make sure you pause this and copy all this down. So in table A, we have the number of books and the price. So it says one book is $3, 3 books are $9, 4 books are $12, 7 books are $21. So my question to you is, do you see, make sure you get these questions down, is there a pattern? Do you see a pattern? And as you look, you should see that the pattern is however many books you have, you multiply it by what? 3. 1 times 3 is 3, 3 times 3 is 9, 4 times 3 is 12. So is there a pattern? Yes. Times 3. That's all you have to put. Yes, there's a pattern times 3. So what would this last one be? If we wanted to buy 15 books, how much would that be? 15 times 3 is 45. Good. So now my second question is it the same every time? Every time in our box that we have, every time in our table, was it the same? Yes, it was the same. So the last question is, what is the constant of proportionality? I'm going to abbreviate C of P. Constant of proportionality, and if you look at your definition, it's that constant multiplier. So what is the constant multiplier every time? And the answer is 3. So the constant of proportionality is 3. I know it's something new, but it's not difficult. It's also the unit rate. Look at the unit rate. One book is $3. That is the unit rate. The constant of proportionality. Let's look at another one together. B. Here we go. Bananas and the cost. So if you want to get 2 bananas, it's going to cost 50 cents. 4 bananas is $1. 6 bananas is $1.50. 8 bananas is $1.75. So make sure you get your table down. Notice I don't have 1 banana up here, so I can't just look at the unit rate. So my first question is, do you see a pattern? So what's happening each time? Do you see a pattern? From here to here, it's doubling. And from here to here, it's tripling. But, so it looks like it's increasing by 50 cents. So it's increasing. But is it the same? So is it the same right here? And my question to you is, what happens right here? So 2 bananas, 50, 4 bananas, $1, 6 bananas, $1.50. What would you expect 8 bananas to be? If the pattern was the same, we would expect 8 bananas to be $2. But right here is $1.75. So is it the same? No. It's not the same. So think with me for a minute. If we had 1 banana, how much would 1 banana cost? If 2 bananas cost 50, 4 bananas cost $1, 1 banana would cost 25 cents. So is that the same ratio as 8 bananas to $1.75? Does 1 over 25 cents equal 8 bananas over $1.75? That is the question. Are those ratios equal? Does 1 banana for 25 cents equal 8 bananas for $1.75? And the answer is no. So is it proportional? The answer is no, a big no. It's not proportional because of this one right here. It changes. It doesn't have the same pattern, and there's no constant of proportionality. Because all of a sudden, it's 1 to 25, 2 to 50, 4 to $1, 6 to $1.50, and all of a sudden it changes. So that means it's not proportional, and there's not a constant of proportionality. All right, example 2. Is the relationship proportional? Is the relationship proportional? And if it is, what is the constant of proportionality? So I've got 2 more tables. Make sure you get these tables down in your spiral. Pause it if you need to. Get these tables. And we are going to do this one first. Serving size. So in a serving side of, I don't know, serving, if you have 1 serving, that means you get 1, I guess, serving of nuts, 2 servings of fruit, or maybe 1 nut and 2 fruits. And then you see 2 servings, 3 servings, 4 servings. So my question to you is the relationship proportional? So are all of the ratios equal? That means we look for the pattern. So in our table, what kind of pattern do you see? So let's just look at nuts. What's the pattern you see? Times what? Times 1, right? 1 times 1, 2 times 1, 3 times 1, 4 times 1. What about in fruits? Do you see a pattern? 1 to 2, 2 to 4, 3 to 6, 4 to 8. Yes, you see the pattern. Is the pattern the same? Yes, because all of these are times 2, and all of these are times 1. So is this proportional? Yes, proportional. And the constant of proportionality. So what's the constant of proportionality? Well, depends on what we're talking about. What's the constant of proportionality for nuts? Every time it's being multiplied by what? 1. So the constant of proportionality would be 1 for nuts. And what would the constant of proportionality be for fruit? 1 times what, 2 times what, 3 times what, 4 times what. Remember, it has to be the same, and it is 2. And remember right here, you can look at the unit rate to determine the constant of proportionality. You can always look at the unit rate to determine the constant of proportionality. Let's look at the other example. All right, movies. So we're going to go to the movies, and it's going to cost us. If we go see 1 movie, it's $6, 2 movies, $12, 4 movies, $24, 10 movies, $40. So is it proportional? So the thing we need to look for is the pattern. Do you see a pattern the whole way through the table? 1 times what, 2 times what, 4 times what, 10 times what? So 1 times 6 is 6, 2 times 6 is 12, 4 times 6 is 24. But is 10 times 6 40? No. So right here is when it changes. So it's not proportional. It is not proportional because it doesn't have a constant proportionality. Now if this said $60, then it would have been proportional. So to answer your question, is the relationship proportional? Yes or no? And what's the constant proportionality? It's going to be that unit rate. All right, so example 3. Now let's look at some equations. Equations. The key with equations is it has to be a multiplication or addition equation. Has to be multiplication or division. Can't have any addition or subtraction. Has to be multiplication or division. So, is it proportional? What's the constant proportionality? Same questions. Is it proportional? What's the constant proportionality? So, question A. Books are $3 each. So, here's an equation. The total cost is 3 times the number of books because they're $3 each. So, if you want 1 book, it would be 3 times 1 is 3. If you want 2 books, it would be 3 times 2 is 6. If you wanted 10 books, it would be 3 times 10 is 30. So does this have only multiplication or division? Yes. So is this proportional? Yes. And what is the constant of proportionality? The constant of proportionality is that number that's being multiplied. So the constant of proportionality would be 3. 3. Let's look at B. DVDs are $7 each plus $1 shipping. Have you ever purchased anything online? So shipping, you have to pay for them to send you items, right? Doesn't matter how many items you buy, you have to pay that $1 shipping. So let's look at the equation. The total cost, it equals $7 per each DVD plus $1 shipping. So let's look at this plus $1 shipping. Is that multiplication or division only? No. If it has addition or subtraction, that means it's not going to be proportional, so this is no. And there's no constant proportionality because it's not proportional. Alright, so C is the distance formula. I'm not sure if you did this in science. So you can ask, I don't know, you can tell me tomorrow if you've ever done the distance formula in science. But distance equals rate times time. Distance equals rate times time. So the rate would be how fast you're going. The time would be how long you go, and then the distance. So is this proportional? Does this have multiplication and division only? Yes. What is the constant of proportionality? The constant of proportionality is what's being multiplied. But in this one, I don't see any numbers. So the constant of proportionality would either be R or T, depending on what you're given in the problem. Let's say you were given that you were going 70 miles an hour, that would be your constant proportionality. Let's say you traveled for 4 hours, that would be your constant proportionality. So it depends on what you were given in the problem. All right, example 4, graphs. So here we go. The last thing is graphs. So we did tables, we did equations, and now we're doing graphs. So for the graphs, make sure you get this down. Graphs must go through the origin, and they must be a straight line. Those are the two things. A graph must go through the origin, and it must go through a straight line. So let me show you. Books are $3 each. It's the same example that we've used. Books are $3 each. So if you wanted to buy...
Mr. Fowler, please call extension 100. Mr. Fowler, or Miss Ann Grant, please.
If you wanted to buy one book, that would be $3. 2 books would be $6. 3 books would be $9. 4 books would be $12. And so on. And what if we bought 0 books? If you bought 0 books, would you spend any money? No. So we would go to the origin. And that's supposed to be a straight line. Sorry if it's a little crooked. But this is an example of proportional. It goes through the origin. So it has to start in the origin. And it has to be a straight line, no curves. And again, you can see the unit rate, 1 to 3. So the constant of proportionality is 3, 1 to 3. Let's do another one. Gum is $2 per pack. $2 per pack. We all like gum. So if you buy 1 pack, it would be $2. 2 packs would be 4. 3 packs would be 6. 4 packs would be 8. And you get the idea. Now, if you buy 0 packs of gum, if you buy 0 packs, how much money will you spend? $0. So that means we start at the origin, and we make a straight line, and this is proportional. Again, it must go through the origin. It must go through the origin, and it must be a straight line. Those are the 2 requirements. All right, so example 5, graphs. Let's do another one. Let's say you go to the fair. All right, the fair comes in October, and it costs $5 to get in the fair, and each ticket is $2. So to get into the fair, it costs $5, and then if you want to buy tickets for rides, they're $2 each. So let's talk about our graph. Number of rides down here. Make sure you get this down. Number of rides, and then this would be the total cost. Total cost. So let's say you ride 0 rides. You're a fuddy-duddy and you don't like to ride rides. You just want to go to the fair and walk around, maybe eat some food. If you ride 0 rides, how much do you have to pay? Do you pay 0? No. You still have to pay $5 to get in the fair. So that means at 0, you're going to be up here at 5. And if you want to buy one ticket, you'd be at 7. 2 tickets would be at 9. 3 tickets would be at 11. 4 tickets would be at 13. And so on. So that would be your graph. Is that proportional? Does that go through the origin, and is it a straight line? Yes, it's a straight line, but does it go through the origin? No. So this is not proportional. That is not proportional because even if you don't ride any rides, you still have to pay $5. So it is not proportional. So I wanted to show you an example of one that was not proportional. The last one is a U-try. And I'm going to give you the equation, the table, and the graph of all three the same things. The table, the equation, and the graph. And I want you to tell me if it's proportional, and I want you to tell me what the constant of proportionality is. So here it is. Perimeter equals 4 times sides of a square. So we're talking about squares. Side length of a square and the perimeter, and then here's the graph. So of a square, the side length is 1, the perimeter is 4. So an equation, a table, and a graph. So you tell me what is the constant of proportionality, and is this proportional? And we'll go over it in class tomorrow.